Hello and good morning. This session focuses on acid and base. The first definition of acid, according to Arrhenius, is proton donor, anything that releases or donates proton, and base is something that releases hydroxide. We call this hydroxide donor, OH. Bronsted-Lowry definition are mainly based on proton. Acid is a proton donor, the same as Arrhenius, and base is a proton acceptor, or anything that removes proton. Lewis' definition is based on electron. Acid something is a species that electron acceptor, and base is electron donor. The next part of this, I'm going to focus on general reaction in acid and bases. Usually you have an HA plus water, and when it goes to base reaction, it creates H3O plus, which is called hydronium ion, and A minus. There is another definition that you need to be familiar, and that's conjugate acid and conjugate base. For every acid, there is a conjugate base. In this reaction, these are the acid conjugate base pair. There is also base and conjugate acid, which are H2O and H3O plus. One of the quick way to recognize which one is acid, conjugate base is reminding yourself that conjugate base has one less hydrogen, something that has lost a hydrogen, whereas conjugate acid has one extra hydrogen. There are a few points to pause and ponder. One thing about this reaction is if H2O is stronger than A minus, equilibrium shifts to the right. And if A minus is stronger than H2O, this equilibrium will shift to the left. Chemists use Ka, which stands for acidity constant, to show the strength of the acid. The higher the Ka, the stronger the acid. Ka for this reaction is always concentration of product or concentration of reactant. So for the above reaction would be H3O plus times A minus, square bracket denotes concentration, divided by reactant, which is HA. Notice I omitted water. Anything that is solid and liquid does not show up in Ka. Few examples to know: acetic acid is HC2H3O2. It ionizes itself into H plus and CH3O minus. So Ka for this reaction would be concentration of H plus, concentration of acetate, which is C2H3O2, divided by HC2H3O2, acetic acid. Another reaction is aluminum hydrate, which is AlH2O6. So as I've written it, if you want to write Ka, again, concentration of the product divided by concentration of reactant. The next topic is acid strength, which I point number 2. Again, starting with this reaction, H2O, HA in H2O, you get H3O plus A minus. Two things to know: strong acid favors forward reaction, so that's one thing you should know. If it's a stronger acid, it tends to go forward, and a stronger acid yields a weak conjugate base. This is very important when we talk about ranking acid or base, which we'll see in a moment. I try to use a graphical representation of what is strong acid or weak base or weak acids they show in an aqueous solution. So if you have a strong acids, HA, essentially nothing is left in a solution. If you look at the beaker of HCl, there is no HCl. Everything is ionized to H plus and A minus. Whereas if you have a weak acid, you have, let's start with HB, you have some HB left, plus small amount of H plus and B minus. And if you're wondering how do you determine how much of this is left, so this is based on Ka. The Ka will determine how much it'll be dissociated. The higher the Ka, higher ionization. The lower the Ka, lower ionization, therefore weaker acid. I like to use this opportunity to list whether a strong acid or strong base. So strong acids are H2S, HNO3, H2SO4, HCl, HClO3, HClO4, HBr, and HI. In nomenclature session, I'll go over the details of how to name this acid or bases. For a strong bases, are group 1 OH, anything in group 1, lithium hydroxide, sodium hydroxide, and so forth. And group 1 OH, group 2 OH, but only heavy metal. And heavy metal are 3, calcium, strontium, and barium. The next part of this, I want to highlight points on oxyacid and carbonic acid. So one thing we should know, oxyacids, they have oxygen, is very self-explanatory. And also is acidic hydrogen is the one that is attached to oxygen. This is important. So not every hydrogen in oxyacid is acidic. Some of them are not attached to oxygen, they're not acidic. The next is a carbonic acid. Carbonic acid are those, they have carbon backbone, like acetic acid that we talked earlier. In this molecule, the hydrogen in this corner is acidic because it's attached to oxygen, whereas these 3 hydrogen that are attached to carbon and not to oxygen are not acidic. So how to rank acids or bases? This is example that oftentimes you've been asked. Your ACE card is use Ka, and usually Ka is provided in a table. I will explain how Ka, Kw, Kb are related. But for this now, as an example, if I give you the list of H2O, F minus, chlorine, NO2, which is nitrite, and cyanide ion, if I ask you to rank them according to a strength of basicity with least basic to the most basic, or they can ask anyway, first write the acid. So they were H3O plus, F minus used to be HF, HCl, and so forth. And write the Ka for these acids. This is the one that you get from a table. You do not need to memorize them. The key is this: the stronger the acid, the weaker the conjugate base. So the weakest the conjugate base is the one that comes from stronger acid, so Cl minus. And the strongest conjugate base is a weaker acid, which is Cn minus. And if you look at the numbers, you can easily rank the rest. H2O comes next, followed by fluoride, which is 7.2 times 10 to the negative 4, as opposed to nitrate, which is, or nitrous acid, which is 4 times 10 to the negative 4. Again, this is a conjugate base of a strong acid, so it's the weakest base, and this is conjugate base of the weak acid, which is the strongest base, strong base. The last topic I want to highlight is amphoteric. In biology, we also talk about amphoteric, something that has both acidic and basic property. Amino acids are example of amphoteric. In chemistry, so anything that acts both acid and base. Water is an amphoteric molecule because if you add 2 water molecules, one could act as an acid and the other one could act as a base. So these are the 2 you get. So plus or minus. So this is the base and this is the acid. Or NH3, when you add them together, you get ammonium with a plus sign and NH2 minus with a negative sign. Again, in one of them, NH3 acts as an acid and the other one acts as a base. These are called amphoteric. I just want to highlight one more thing before I stop. There is another terminology called amphipathic. Amphipathic is molecule that has both polar and non-polar. The examples are lipids or fats. Fats or lipids are called amphipathic. So I hope you find them useful. Thank you for your attention, and I wish you well.